Good evening, everyone.
Good evening, Jalen.
Hi. Here's my
Good evening.
for this week. Last week we complete the exploratory data analysis, which is EDA, which helped us identify key patterns and relationship in the data set. That was important to make sure we are focused on the right features for our models. So this week I start testing the random forest and XGBoost model to establish a baseline for how well they perform with our data. I'm focusing on the fine-tuning the hyperparameters of these models to improve their accuracy. Once I get good results, I start experimenting with natural networks to see how they can further enhance our predictions. Um, the goal for this is to see if deep learning technologies like dropout and batch normalization can help us model capture more complex patterns. So far, based on the EDA result of last week, and I'm starting working with the models this week, and the next week is still continue with this work to turning them. That's all for this week. Um, and if you guys have any issues or risks that you want to synchronize, you can we can leave some time for discussion. That's my part. Here goes to Chen.
Thank you, Jalen. This week, I've been focusing on learning how to build models with various algorithms, including logistic regression, key nearest neighbors, support vector machine, naive Bayes, decision trees, random forest, and XGBoost. I've been exploring the strengths and weaknesses of each model, particularly on how they handle different types of data and their performance in terms of accuracy and computational efficiency. For example, I've learned that XGBoost is particularly effective for handling missing data and large data sets due to its boosting technique, which it which improves performance. Currently, I'm applying LR to our Cleveland heart disease dataset. Before jumping into the model, I spent time on data processing steps, including handling missing values, normalizing the features, and splitting the dataset into training and test sets. I am now working on fitting the LR model to predict the presence of heart disease. LR is a pretty good starting point since it's simple and interpretable, allowing us to understand how different features contribute to the prediction. One challenge I'm facing is ensuring that the data is properly pre-processed before fitting it into the models. For example, dealing with missing values in some features or determining the best approach for feature scaling, especially with algorithms like KNN that are sensitive to distance. And that's pretty much my part for this week. Uh, let's hear about what Chelsea did for this week.
Thank you, Qianying. This week I also learned the linear regression model, k-nearest neighbor model, and the support vector machine. And I also did some data pre-processing for the data. I handled missing values by using the median algorithm, and also used the a classification model for some missing values, and I don't know which performs better yet. Also for the linear regression model and the KNN, I feel like sorry, linear regression may not be a good model here. So KNN and support vector machine, I think they are good classification models. So I studied a lot on it. And last week's exploratory data analysis, I think we can use the heat map to extract the important features for the support vector machine. Will be super useful. And do more data pre-processing for this model to make them more accurate. And yeah, I will hand it to Xiaoyu.
Thank you, Chenxi. This week, good evening, everyone. This week, I've been focusing on both the technical and non-technical aspect of our project. For the technical aspect, I've been learning various machine learning models, including logistic regression, KNN, support vector machines, decision trees, and XGBoost. I plan to explore hyperparameter tuning further, especially for models like XGBoost, to improve our performance. And currently, I'm building a KNN model using the Cleveland heart disease dataset. I use KNN because it's simple yet effective for classification tasks. And it helps me get a clear understanding of the data before moving on to our more complex methods. Some challenges include handling the imbalance in the data set and ensuring the model generalizes well. I will be using cross-validation and feature selection to address these issues and avoid overfitting. Okay, now on to the non-technical side of the things. As we all know, to better prepare our team for our project, I've been organizing a few team building activities. For example, we're planning a rock climbing session to build stronger body and sharper minds, which should help us stay energized and focused. We've also been sharpening the clothes, as our appearance can play the part in delivering a professional and confident presentation. Additionally, we've been practicing English conversations to ensure we communicate our ideas clearly and effectively during our presentation. Lastly, we are considering a lavender viewing trip this Saturday as a way to recharge ourselves as a team. I believe these activities will not only strengthen our collaboration, but also prepare us for the subsequent stages of the capstone project. Okay, that's all from my part. I will pass on the time to Xiaoyu. Thank you.
Thank you, Xiaoyi. So now I will introduce my part. So this week, I focus on studying and analyzing 7 machine learning models from the paper. So those models include logical regression, support vector machine, and the decision trees. So I explore how each of those models performed on the heart disease dataset. And my primary test involved understanding the structure and the functionality of those models and how they contribute to disease prediction. Additionally, I worked on the data processing, so which involves cleaning and normalizing the dataset to ensure that it was ready for the models to progress. And this including handling the missing value, normalizing the data, and ensure all future were properly formatted for analyze. So next week, I plan to divert deeper into understanding the results generated by those models, specific focusing on the performance metrics like recall and F1 score. So my goal is to comprehend how those models compare against each other and which one is the most efficient for heart disease prediction. I will also explore the next step in refining the chosen model to improve its prediction. So I might also start experiment with the more advanced technique. So that's all for my part. And I think that's everything for today's meeting.
Thank you, Xiaoyu.
Okay, so
Everyone, good night. Have a
see you
good
next
night.
see you next week.
Thank
See you
you.
tomorrow.
See you.
Bye.
Thank
Bye-bye.
you. See you on Saturday
Bye.
for the lavender.
Saturday.
Yeah,
Yeah.
Saturday.
Yeah.
Tomorrow and Saturday. Bye bye.
On Saturday.
Bye.
Bye bye.